Ladies and gentlemen, please welcome Research Vice President Mindy Kinsella and Research Vice President and Gartner Fellow Danny Bryan.
Thanksgiving Day, 1982. I was just 10 years old, and my dad's office building basically burned down to the ground. This was Minneapolis, the headquarters of Northwestern National Bank. And it's one of my most vivid and scary memories from when I was a kid, seeing this news footage of the fire and also visiting the aftermath after the fire happened. We visited this site just the next day, and my first thought was, how can anything burn in this Minnesota cold? I fully expected my dad would have to find a new job. His office building just burned to the ground, the bank. I remember my mom saying something like, better save the Thanksgiving leftovers, kids, because we could be living on the street soon. She was a bit dramatic like that. I wasn't allowed to enter the building, but my dad was, and he kept a souvenir. Combing the charred building remains for personal belongings, he found and he kept this phone. Here's Dad.
Well, after the fire, I was able to go up to the 15th floor to retrieve some things, and this phone was in the computer room, so it survived the actual fire because it came on gas. But everything in there was totally melted. I wish I had a copy of the computers. They were melted just like this. It was surreal.
I'm not sure if he was supposed to keep the phone or take it from the building.
I'm going to guess probably not.
Probably not. But imagine my surprise when he returned to work the very next day.
Northwestern National Bank lost much of its headquarters.
Probably no one will remember this fire better than employees and customers of Northwestern National Bank.
The downtown office remains shut down. But tomorrow, all Northwestern Bank branches will be open at 8 in the morning to 1 o'clock tomorrow afternoon.
Much of the building went up in smoke, but not the bank's records, much to the relief of worried customers.
I got a picture coming from there. They put it over at the main office. But I asked them, see, they do everything is okay.
Checking accounts, savings accounts, and mortgages all are duplicated and computerized, so there was no problem conducting business normally done through the main office.
The Northwest had a detailed plan to help them prepare for exactly this type of a catastrophe. And it was outlined in this 1983 Harvard Business Review article authored by Virgil Dismeyer. Virgil was responsible for architecting the bank's disaster recovery plan. And the article outlines the exact questions that they required the business units to answer precisely so that they could prepare for this type of a catastrophe.
I heard all kinds of tall tales about this fire when I was growing up, so I had some of my own questions. We were able to track down Mr. Dismeyer, and the first question I asked him is, how are they able to prepare properly for such a catastrophe?
A recognition by management that we just had too much risk in one location. So I got authorization from the board to build a separate operating center. Now, if they had still been in that building, it was, I think, been a completely different story. We had a lot riding at 7th and Nicholas. Too much.
Most of our organizations have good disaster recovery plans in place today, I hope. In fact, it was this fire that prompted regulatory agencies to require a disaster recovery plan from financial institutions. But I want to highlight this: too much risk in one place.
And not necessarily in one physical location, as was the case with the bank, but what about betting on one vendor, one set of tools, one set of solutions? I have to ask, how much risk do you have in one place, and are we properly preparing for such risk effectively?
Next, I asked Mr. Dismeyer what key lessons they had learned.
But I think the biggest thing I learned from our fire and then working with other banks was that IT seemed to think if they had a backup plan, that's all the bank needed. And they forget about all the unique needs that, say, a trust department might have. Doesn't do any good to have the IT running. That was the lesson, that you have to think beyond IT. Sure, it's the backbone. You have to look at the workflow. Their thinking stopped at the IT. I think most IT managers have gotten past that, you might say, isolationist view of themselves and think of the entity as a total.
Wow. He was so forward-thinking. Are we thinking beyond IT today? I work with organizations daily, and they're still struggling to break down these traditional silos. Now, we're going to be talking a lot about practitioners today, as you are the target audience for this conference. Do we think of the organization as a whole?
That was 35 years ago, talking about isolationism in IT. So do we deserve all the credit that Mr. Dismeyer gives us, that we no longer have that view of IT? Are we building solutions that empower people properly, or are we still stuck in the old ways? Are we giving people choice? Are we giving them things that make them more autonomous than they've ever been before? I also asked both of these men what the silver linings of this disaster were.
The biggest silver lining is when they designed the new building, of course, they wired it completely for digital.
It allowed the bank to rebuild total fiber optics, had to be trained on computers, word processing, email, Excel. Unfortunately, a lot of the officers of the bank didn't make it through that traumatic time.
The PC, the terminal, everybody did.
Instead of having to cut and paste and deal with small budgets to improve the IT insurance proceeds from the fire, we were able to scrap the whole system and create a whole new system all at once. One large jump at one time. The ability to do that was one of the main factors in Northwest in 10 years when the bank was having some problems to the best performing bank in the United States.
You know, Danny, the bank fire became a catalyst for Northwest to completely digitize the company when no one else in their industry had yet.
This reminds me of a concept that Gartner's been writing on lately, the digital escape velocity. This is where you reach a point of innovation where you significantly outpace the competition, making it really difficult for them to come up. Now, Northwest was not a digital business yet. That's not our point. My final question concerned any mistakes that were made.
Yeah, one of the mistakes that we made was that we weren't strict enough in keeping employees out of the facility. We probably didn't have enough guards to keep them all out if we wanted to, but everybody wanted to go in and look at the ashes, wandering around, looking for stuff that no longer exists.
Good old dad.
Now, it took until 1988 to complete the new building, and I can only imagine how difficult it must have been for them to manage all of the logistics and the operations until the new building was complete. But by 1994, Northwest had become the 11th largest bank in the United States.
And they eventually merged with Wells Fargo. Now, Northwest was the larger and more successful of the two organizations, but they kept the better-known name of Wells Fargo. And that became the largest bank in the world by market capitalization in 2015. As their mug said, they certainly had their ashes in gear. So this story comes full circle for me because my first IT job was at Northwest. I was a Solaris administrator, and part of my job was to go around and implement the disaster recovery plan, swapping out backup tapes. No, not these tapes. I'm not quite that old. Those tapes. A lot of people probably don't even get that joke. They just think both those things look really old. And changing those tapes was almost as much fun as watching this video. So let's go back to the time of the fire and talk about what was it like to be an IT practitioner back then.
These are the pages from the exact same newspaper, and they're just a few pages after the bank fire headline. And many of us, I'm sure, remember this computer electronics boom. We went from computer ads only being in Compute Magazine, complete for you to enter the basic source code yourself, to consumer ads like these.
I liked entering that source code. That was fun.
Oh, Danny, I'm sure you did.
Now, the cost of a gigabyte of storage in the same year that the bank burned down, 1982, was $250,000 US. Today, it can be less than a penny, depending on the medium. You know, part of your job in IT back then was to protect this stuff because it was so expensive. We couldn't have done certain things like processing big data or implementing complex AI algorithms because we didn't have the capacity. It would have been cost prohibitive. Now, storage is basically disposable. Mr. Dismeyer recalled the first computer to ever arrive at the bank.
Management really didn't want to be bothered with this, newfangled device. I know the first computer at the bank, we had it in an air-conditioned room with floor-to-ceiling glass so we could show it off to our customers. And so we had regular tours. It's like going to an aquarium. Cloud computing, we've got cell phones. We had to deal with landlines. It would have been easier with cell phones.
A lot of things might have been easier with cell phones.
Perhaps reputation for being siloed in IT isn't entirely our fault. I mean, management needed us to be siloed. They need architects to focus in their areas of specialty, and therefore we were intentionally siloed. And as you said, Danny, this stuff was so expensive, we had to wear white gloves and slippers.
And thank goodness that's changed. We no longer require a workforce, a specialized workforce, to insulate us from the technology, like computers being in an aquarium.
We're here today to talk about the 3 keys to architecting your digital future. But first, let's talk about what it is that we architect for today.
Well, today we architect for assumptions, facades, lies perhaps. We say things like architect for scalability or stability, or architect for agility or cost or security, whatever it might be. But the truth is, these are not the underlying goals of architecture.
You're right, these are little more than a blanket list of non-functional requirements. For example, if scalability is your #1 priority, you could spend millions of dollars putting all of your resources into achieving that goal of scalability, only to build the most scalable platform and have no one use it.
And it wouldn't be the first time. Non-functional requirements are basically our modern CYA list of stuff, checking off the boxes, covering our ashes. Our argument today to you is that we need to get past these blanket assumptions to understand the underlying trends, the core reasons that we architect, the fundamentals of architecture. That is our goal today, regardless of project, regardless of requirements. What must IT architect for going forward?
The bank story gives us good insights into the trends from the past. We're going to look at these trends and how they've changed through time by looking at case studies like the bank fire, as well as ones from the present, so that we can use this to identify what it is that we must focus on in the future for our architecture.
And consider what's happened in the past decade or so. These here are some of the primary forces driving change in technology, all technology, including these 3 keys we're going to tell you about. Now, Gartner terms a subset of these the nexus of forces, if you've heard that term before. What these forces do is they push us up a ladder of concerns. We can no longer architect for the same things that we were architecting for 10 years ago.
Nope. We have to look at the trends and how they've changed through time to be able to answer that question of what it is we need to architect for in the future. What are those things that are guaranteed to increase, guaranteed to accelerate? This will provide the proper perspective not only for our architecture, but also for our careers going forward.
So IT practitioners in the past, they were siloed. Their job was to protect and safeguard stuff as much as anything else. Single centralized systems, highly manual, not particularly precise, not very scalable, but most importantly, we're not putting solutions into the hands of people yet. And part of that's because it is so expensive. We need it to last a decade or 2, perhaps. Portability, that's not even a term that we use yet.
As we move into the present, these silos, they just don't work anymore. And this change is largely driven by the adoption of technology. We constantly learn, we innovate, we automate things. Rather than teams being isolated and computers behind glass walls or aquariums, as Virgil called them, everyone embraces technology as part of their everyday life. And as a result, we all become far more technical. It's changed the way that we work, the way that we communicate, and it's even impacted the solutions that we buy.
Yeah, if you remember the non-functional requirements we discussed, I mean, today we get things like security and compliance and speed as much from frameworks and tools as we do from some of the things that we architect. Scalability and stability are things we increasingly get from cloud services. The problems of the past are kind of being solved for us at this point. So we need to elevate our goals to new ones.
That's right, it's elevated for everyone. We could even argue that the whole idea of a practitioner of IT must become far broader, because people who aren't in our profession are becoming more technical and capable, and they're likely solving and coming up with solutions on their own.
Whereas we had to solve them in the past for them.
Exactly. So I have a personal story on this topic. I went to the dentist for a routine exam, and I received the dreaded news that some of you may have received before. I had a 20-year-old crown that needed to be replaced. You see, I had a bit of a candy habit as a child, I frankly still do, and that didn't bode well for me.
Remind me to tell you my root canal horror story. It's not appropriate for the stage. But here's our conference chair.
How do you feel about the dentist?
Kirk Shield doing a pretty good job of expressing how I feel about the dentist.
Start drilling.
My old dentist, he would take impressions, and I'm sure some of you remember waiting for that gooey material to set. Well, he sent it off, and he just didn't get a good impression. When the temporary crown came back, my bite just wasn't right. He was never able to get it precise. I kept having to go back for him to refine this, and I finally grew frustrated, and I started looking for a new dentist.
You find one?
I did. His name's Dr. Rhodes, and he has a completely different approach.
Kind of the revolution is being able to bring this into your office, do it directly in a patient's mouth. There's no inaccuracy. There's no transfer of impression to stone to models, and they get bumped and bruised, and you scan that. And you kind of essentially just merges those two data sets and gives you everything in between.
Let me explain what he means by merging those two data sets. So first and foremost, everything he does is digital. So he takes a wand, basically, and captures a digital image of your mouth, your bite, so it's precise, 3D rendered. Then he does the build-up. Now, bear with me, those are my technical dental terms. But he basically creates a delta of the two images, all software-based. There's no impression.
I'm still trying to get over him saying merging of data sets, your dentist saying that.
I know.
And I'm a bit reminded here of the bank story. Getting rid of that transfer of impression, if you will, by embracing computers, putting them on everybody's desk. Put the technology in the hands of the people who need it to be productive. We're getting rid of a lot of this unnecessary process.
Yeah, you're definitely right. There's a trend here that we're seeing, and you can see it completely with the dentist story.
So kind of the two images are stitched. So then as you move forward in that process, you can see that it's down to something that's like a good solid foundation.
This is incredible to me. Now, I assume he takes this file and he sends it to the lab, and they make the thingy, and they send the thingy back to the dentist.
No, wait, there's more.
Oh.
I mean, in terms of the hidden mail, if you like what you got there,
Really?
Material selection items, we'll give you a preview of the item. And see there, it's kind of in this blank block. And you just hit start, and it cues you to go put the thing in the machine over there and hit go.
He machines the thingy right there in his office.
And this isn't a temporary crown.
No, this is the permanent crown.
What kind of material is this?
That is a lithium disilicate.
Oh, a lithium disilicate, of course.
You know, the craziest thing about this is this took 15 minutes start to finish, where my previous dentist, it took about 3 weeks, and then I had to keep going back to get it refined. And by the way, it was never really right.
Okay, so this guy's completely autonomous. He has no dependencies at all. He's able to kind of refine these things, these 3D models in software. He's disposing of each one and refining it as he goes. He You can probably machine these repeatedly if something goes wrong, disposing of the old ones. And the precision of these software tools is kind of ridiculous to me. Is there any downside here? Is this just all good?
Well, it was definitely all positive for me, but let's ask him.
Honestly, yeah. I mean, it's impractical. Basically, to take something that's you can do this simply and actually wait for years to make something that's really repeating on multiple levels. You know, even if the timber comes off and it's not uncomfortable, it's still not really super nature. When you go around 3 weeks or something, it's not sort of stuck up your tooth. It's in here. Within a half hour, it has to be permanently going to fix that substrate, just for it super clean. There's no contamination. I've never been with the quality of something that fits so perfectly.
Sorry about the audio there.
Geez, Danny, you had one job.
I had one job. Well, I am sold. Where is he located?
He's located in Austin. So let's check out the final product.
Stops. Yeah, so it mills right to the very end and just enough where it actually comes right off.
And this really made me think differently about technology. I mean, here I am at the dentist, and how this has impacted not only his business, but so many others. My other dentist, he basically lost a patient because he just couldn't compete. The speed that he could deliver along with the quality of the craftsmanship, and it's due largely in part to technology. I mean, I guess you could say he achieved digital escape velocity.
Your dentist. A dentist achieves digital escape velocity. Not something I would have thought of before.
Yeah, today we're seeing a dramatic increase in the level of accuracy and precision, the quality of the technology. It's empowering professions like the dentist in 2 different ways. And a big part of that is the empowerment in people, allowing them to iterate, to commit, to change things in software before they commit them. Now, this isn't necessarily a new trend, but we are witnessing the emergence of software-defined everything.
Yeah, the software-defined everything is where we're moving things that used to be in hardware into software. Think of keyboards on a phone moving into software, rendered on a touchscreen device, or networking switches moving entirely to software. I mean, there's so many examples of this. We could just go on and on. Part of the reason we're doing this is because software is disposable. And I can't help also but think of platforms that embrace this disposability dynamic concept, like cloud.
Yeah, or containers. When you talk about these things being software, the idea is that you can dynamically spin up and down resources as needed.
All software control, all dynamic. Software is also the reason we're able to innovate things that we couldn't even conceive of before, because physical things didn't allow us to do that. We're empowering people, taking away the dependencies that they have today. Why? Because software is better. Software is cheaper, it's changeable, it's malleable in all the ways that physical things are not. Think of it as the clay is the code is the clay that never dries, okay? It has no environmental footprint, if you will, and this encourages experimentation and constant iteration. Which brings us to the inevitable discussion about the future. We're not here to predict the future to you, only to discuss the certain trends. And these trends are very well illustrated in a couple of examples, starting with Tesla autos. Now, we're all familiar with Tesla. It's hard to avoid news about Tesla these days. But let's talk about what they're doing to architect their digital future.
Yeah, I recently had the opportunity to drive a Model S. And the first thing that caught me off guard is that this automobile, it doesn't even have a power button. You get in it and you just start driving. It's entirely battery powered. It offers complete autonomy. You get in and the entire dashboard is rendered in software and completely gets updated over the wire. Oh, and by the way, it happens to be the quickest production auto, 0 to 60, if you're into that sort of thing, which I kind of am.
Of course. I'm more interested in the lack of a power button. I think that's like one of the most innovative things I've ever heard, that you don't turn this car on. Now, the Tesla Model S is at version 8.1. I love that. That's the software version. But just as cool, as Mindy said, is the release of totally new dashboards, disposing of the old dashboards. Things like autopilot constantly being refined and improved. This vehicle collects data on everything you can imagine, from the vehicle performance to the road conditions to traffic trends and conditions. And then they use all that data to improve the vehicle constantly.
And Elon Musk isn't stopping there. He's taking this innovation and he's carrying it back into the factory. He wants to increase the production speeds from 5 centimeters per second to 1 meter per second. The fact that he can even think in meters, it's all based on the technology and the automation. If he's successful at doing this, Tesla will produce 5.2 million cars on a single production line, whereas traditional manufacturing standards are about 400,000. Talk about achieving digital escape velocity.
Yeah, we're talking about automation here. The trick is to create the machine that creates the machine, as Elon Musk likes to say. This automation gives Tesla extreme precision. Now, speaking of precision and talking about massive amounts of data, we have to jump to StatCast, because we're both huge baseball fans. So permit us a tiny bit of indulgence while we use the sport to talk about the future here.
Now, if you're not familiar with baseball, statistics are a major part of the game, in part because it's a zero-sum game. In baseball, everything is expressed as a percentage, batting 500. Even a team's win-loss is expressed as a percentage.
Exactly. Everything has to balance out in baseball. If a runner scores a point because of an error on the opposing team, say somebody drops the ball, the batter doesn't get credit for that score, the run batted in, the RBI. Instead, it counts as an error against the other team. Anyway, this equation of balance in the game is very important to baseball. With 162 games per year, per team, 30 major league teams and hundreds of minor league teams, it's a ton of data on which we can draw insight. It's a very precise sport. Now, StatCast is the next generation analysis system of Major League Baseball. Here is Joe Inzerillo, the CTO, describing how they are architecting the digital future of a sport.
We've always wondered about things in baseball. And one of the things we've always wondered is player positions and how they affect the game and the dynamics with the ball. So for example, what's the reaction time of a shortstop? Did he go the right direction? Did he take the right route to get there? StatCast and player tracking were designed to really give the fans the insight, to give them the ability to see things that they previously hadn't seen. What would professional sports be without slow motion instant replay? Just wouldn't be as exciting. We think this is the next generation of that, the ability to actually see data occur in real time and be able to judge it and compare it in real time is a real insight into the game that is going to be just as impactful over time as slow motion was. What StatCast is really about is giving people empirical information to power that conversation at the bar, which is a huge part of what sports is. And ultimately, people are fans of players, they're fans of teams, and they want to be able to say why their team is better or their player is better than the next. StatCast really has this notion of being able to provide insights into the game that were just previously not there. So everything starts on the field. We have players, umpires, the ball moving around, and we have to track that. And the way that we do that is with stereoscopic machine vision and radar. The combination of those is gathered and assembled at the ballpark and then sent into the AWS cloud for processing. The arithmetic of data points flowing around the field, turning into things like a home run, a route efficiency, all happens in AWS and EC2. And we're using some of the high-level services to trigger functions in there, like Lambda and Kinesis. And then we're using some of the distribution side, like S3 and CloudFront, in order to get that to the customer. One of the things that we wind up having is a bunch of information coming in at the same time, and a bunch of processes that have to kick off in parallel. For that, Lambda is a very important technology that really allows us to have trigger-based processing, where we can send a bunch of things off, and then we can collate them back at the end. Kinesis is a great single job processor. And we use a combination of Lambda to Kinesis to actually kick off very elaborate jobs that will come up with a result that can then be turned into something that is of interest to the fan. By using AWS to power StatCast, which we believe is one of the most innovative things we've done for baseball in a number of years, we're ensuring that our sport is relevant, important, and centered to life for the next generation of fans.
The trends that we've been talking about all along, they're so clear here. Cloud gives MLB on-demand resources as they're needed. The precision of the system, it's so obvious. And by putting the data into the hands of fans, managers, players, it's so useful and empowering.
We've been talking about the future with solutions that exist today, but the truth is these are the approaches that we need to be adopting right now within our own organizations and also within our own careers. But fine, let's gaze into the crystal ball for a moment and ask, what is the future of dentistry, for example? Will those software and tools be able to eventually provide diagnosis?
Why not? We've got these crazy intuitive programs that are just doing unreal stuff. I don't know what's going to come, but it's going to be pretty cool, whatever it is. One of the goals is to have sort of a virtual patient, like when I'm working something up, a whole treatment plan, I'll take photos of their face, extraoral, intraoral, get a 3D scan, I'll get a scan of their mouth. I don't even need a patient most of the time to actually work up an entire case. Like I could really never set eyes on them. That would be irresponsible at this point. There's things you can certainly miss. It's sort of in that direction, So at some point, that like a virtual patient will probably be possible. Maybe stick your head in a kiosk or something. I don't think there's somebody who really that's
Well, Kirkshire would love the idea of that kiosk.
Yep. I'd have to think about that a bit.
It makes me wonder, how are traditional dentists going to compete in this environment? Is it all or nothing, traditional against the modern?
There's nothing wrong with like the traditional way as far as like the quality is delivered to a patient, but it's just how you get there consistently. How do you make that efficient, quality, consistency, and just right there in-house? You just can't do that. Short of having an entire field of like lab technicians on it all in your office, right? Some of this stuff, like you cannot do it from conventionally. To get that level of detail, you can't see that well what you've just done. If you can't blow it up on an HD screen, like here's my crown margin, the entire thing. I can tell, man, that's not as smooth right there. It's getting easy to kind of be all those things to a patient and have the control all under one roof. It's all me. So if any patient can look at me and go, hey, we screwed this up, I can say, yeah, sure did. That's what went wrong. Let me fix it. It's nice to just be able to have that level of control, and also that's my commitment to my patients. I'm going to do the best I absolutely can. So if there's something I can't do, I'm going to send it out to a lab, to a specialist, or whatever. And as long as I can control that, then I'd like to do it for the people that kind of they trust me through years.
This is so cool. It's not even about technology to him. It's about taking control. It's about him being empowered, owning his profession. It's like we're reclaiming personal responsibility here by getting rid of these dependencies.
I think we're ready to unveil the 3 keys.
We are. So let's remind everybody, these are the keys we must architect for. These are the underlying motivations. Why are we architecting? What is the job of architects?
We've been talking about the 3 keys in each of the case studies that we shared with you today. The first of these is precision. We must architect for precision. Historically, we planned for peak capacity. We were really imprecise. We overbought because we didn't know what our budgets might look like in the future, and we didn't know if we would be able to meet the capacity needs. But let's look back to see where precision was in the case studies from today.
Of course, they wired it completely for digital.
It's all fiber optics.
No inaccuracy. There's no transfer of impression.
They had to be trained on computers, word processing.
So you scan that, you kind of essentially just merges those 2 data sets and using everything in between.
PCs and terminals on everybody's desk.
No contamination, I've never been able to the quality of something that fits so perfectly.
Precision starts with digitization. It's control, detail, accuracy, exactness. We saw it very clearly in the stories of Tesla's data collection to improve constantly, and also the MLB stack crunching that goes on. The smallest of increments of power consumption being measured so that they can improve efficiency over time, or the exit velocity of a baseball leaving the ballpark.
Or in capacity. Today, with on-demand resources, if we architect systems properly, we don't need to throw overly powerful servers into the rack. We can scale resources as needed with precision.
Another example is in the software that we build. Part of the reason that apps are so successful today is that they are fit for purpose. They are precise, they are small, they are accurate in the needs that they address for users. And they are precise in many other ways, including data and analytics that we have hopefully been collecting over the years. And this is compared to the massive do everything for everybody applications that some of us still have to live with. Our point is that the old ways break down here, okay? When we're dealing with all this data and AI and so forth, neatly mappable relational database tables, okay, or contract-oriented, command-driven systems, they're often not up to the task. They don't match the real world. Instead, this is one reason that event-driven architecture is on the rise, with its many-to-many messaging, smaller messages, smaller payloads. We're getting more precise in our architectures. We're not just talking about data here, we're talking about entirely new approaches, philosophies of how we approach IT. To architect for precision, ask yourself a few questions. Can you deliver solutions instantaneously at the very moment that they're needed? Are you discovering new and hopefully surprising uses for the data that you're, of course, collecting everywhere? Are you allowing that data to change the way that you operate? Do you have the ability to change the way that you operate based on insights you glean from the data? Are you minimizing all project scope? Do your apps and services have the proper granularity to them? And perhaps the most difficult question here, are you solving the right problems to begin with? Now, the second key to architecting your digital future is probably my favorite, and this is disposability. Now, hang on, I know what you're thinking. We can't architect for disposability. Well, we can, and we must, because the only certainty is that change will continue and even accelerate. Do we really have to remind ourselves of the past 20 years of deprecated solutions that became the ball and chain of IT? We don't want to go down those roads again. They lead to dead ends, and we know that. So where is disposability in our use cases, our case studies? How about the bank burning down?
We just had too much risk in one location.
Scrap the whole system, one large jump at one time.
Essentially hit mill if you like what you got there.
Now, if they had still been in that building, it would, I think, been a completely different story.
And at some point, that like a virtual patient will probably be possible.
Checking accounts, savings accounts, and mortgages all are duplicated and computerized.
Disposability is core to modern computing. It means scalability, portability, risk mitigation. And we saw disposability in the way that MLB StatCast is using on-demand resources in the public cloud, or in the way that Tesla updates their entire dashboard, disposing of the old interface. But after my dentist story, here's my favorite summary of disposability.
They're adjusting on it and messing with it and stuff like that, and it can be really frustrating. And it's like it'll fit in there, but I just ground like half the anatomy out of it. And those are the times when it's like you really want to like bite your lip until you're just I gotta redo this. Or if it's your fault, you take a bad impression, and you back a margin that's just kind of open, and you just see it anyway. It's gonna be another 3 weeks. I'm sorry, it's my fault. You know, then it's like 6 weeks out. And it can be a nightmare. But if that happens to me, it's like, hey. 10 more minutes, we'll have another one. Just no worries.
I love seeing this through his eyes. I see zero fear of failure there. That's what disposability ends up giving us. It's about modularity and iteration. We're taking big decisions and risks, and we're shrinking them down, modularizing them, compartmentalizing them, making them small risks and small decisions that we can iterate over and over on, and everything can benefit from iteration.
So to architect for disposability, think about these questions. How quickly can you recover from failure? What is the cost and effort required to migrate away from every solution that you own today? Does every solution have a simple way to export all of that data that it's generating? Are you able to adapt your skills quickly? And finally, do you enable reuse and modularity in everything you build today? Which brings us to the last key to architecting your digital future, and that's autonomy. Autonomy is something we have to prioritize. We have to build systems that empower people like the dentist, but not just people, also machines to be more productive, to take ownership for their work, and to be more independent. Like the dentist being able to create a new crown in a matter of minutes. Siloed IT, it's just a relic of the past.
Yeah, and to architect for autonomy, we're building things that expand people's capabilities, automating things that we couldn't before. Tesla's autopilot, obvious example of autonomy, but we saw many others here.
Kind of the revolution is being able to bring this into your office, do it directly in the patient's mouth.
That was the lesson, that you have to think beyond IT and think of the entity as a total.
It's getting easy to kind of be all those things to a patient and have the control under one roof.
Tomorrow, all Northwestern Bank branches will be open at 8 in the morning to 1 o'clock tomorrow afternoon.
Just can't do that. Short of having an entire field of like lab technicians on it all in your office, right?
It would have been easier with cell phones.
There was no problem conducting business normally done through the main office.
It's all leads. So hey, patient look at me and go, hey, we screwed this up. And I say, yeah, sure did. That's what went wrong. Let me fix it.
Architecting for autonomy means expanding the sphere of influence for what an individual is able to accomplish. It's all about giving them independence. The reason the mobile explosion happened was because we suddenly became far more autonomous than we had been before. And technologies like machine learning and digital assistants, they're making this happen all over again.
Minnie's dentist, one-man shop, zero dependencies, he's totally autonomous, and this lets him deliver higher quality, faster, and I would say with a degree of pride in what he does that maybe would have been difficult to achieve previously.
Or in the case of Tesla, I mean, they have the ability to produce